the most masculine object, so there's a feminine part. And it's at a certain height. Yeah, good one. The lady of the manio, la dame du manio, is on the ground, and we're east-west with respect to the standing stone there. Donc on est à l'est-ouest du grand menhir, on le voit à travers le broussaille, et cet axe-là vise le menhir. Si vous venez de ce côté-ci, if you come on this side, you can see that this axis points straight to the grand menhir there. South axis. You see the stone there, it comes through here, it goes onto that stone. I've taken a picture here of midsummer, midday, midwinter, midday. You see the two shadows of the stone, that stone. Donc ça, on est au nord, donc ici on a une porte. Like you cut it out here and cut it down there. Mirroring.
We are here meeting with Richard Heath, who's authored a number of books, mostly centered on astroarchaeology. His last book was called Sacred Number, and he's been investigating how number could have arisen amongst early megalithic civilizations, and he's going to share with us some of his findings which he has built up together with his brother Robin Heath, and he's brought with him a very simple apparatus to demonstrate some of these principles in practical terms. So Richard, can you set the scene, please?
Well, there's been a problem with the megalithic period that exists in a kind of vacuum caused by the fact that the history of science and mathematics began according to what is the evidence that's been found in the Fertile Crescent, and that there evidence of little counters have been found that are made of baked clay, and these baked clay elements have different shapes and can give us numbers in the form of a 1 for a stick, say, a round object, little round object for a 10, and sometimes it could be a pyramid for 100 or 60, and then larger objects. And this was evidently used for the organisation of trade in particular, because with the Neolithic revolution that occurred in the Middle East, the rapid growth came through the trading of objects and the trading of agricultural goods. And the creation of cities took place. But this took place in the Middle East about 4000 BC, and the process was occurring in the northwest and west of Europe, all the way down to Africa, which we call the Megalithic period. Its traces have not been of obvious numerical counting, in the same way. And it appears that in the megalithic period, the interest was on recording the time counts of celestial objects. So the story differs in the sense that the interest was in the cosmic in the megalithic period, whereas in the Middle East it was to do with what was to become the important basis of trade that would eventually become the norm in the Western world. To design megalithic monuments, the only record that the megaliths that we have of the megalithic period is the megaliths. That's how they got their name. Large stones separated by long distances in patterns that are argued over to this day as to their meaning and what purpose. To design anything involves geometry and measure, and this really is number in an implicit form. But how can there be megalithic design taking place in megalithic Europe if there was not the notion of number, or if they were not using numbers? And this is the sort of problem which has dogged the interpretation of megalithic monuments over the last 50 years in particular. And science does not want to give, official science, a particular credence to the idea that numbers and geometry are indeed pointing to an independent development of a type of mathematics. And the thesis that's really emerged recently, which may break this deadlock, is that the time factoring of counting can produce lengths, and that these lengths are indeed measures through which you can build and design without having an explicit form of number notation. So what they counted is fairly obvious to us today, although it's become less obvious than perhaps it should be, because we do not spend that much time giving heed to the regular patterns of the celestial objects. And the cycles that can be counted are the day, the month, the year in days, and a lunar year of 12 whole months that fit within the year but come somewhat short. And the first example of how numbers interact implicitly through counting in lengths can be found through the mutation really of late Stone Age bones and plaques, in which supposedly decorated objects have been found, and particularly interpreted by Alexander Marshak in his book The Roots of Civilization. These have been interpreted as being counts almost always of the two of the lunar months, because if every mark represents a day, one tends to see enough marks to have counted 2 complete months, and sometimes the marks represent visibly elements of fullness or crescent nature to the moon, or indeed its absence as a new moon. Now the solar year is 12 of these lunations, but the 2 lunations give you the first real fact that they could have learned, which is an accurate approximation to the length of a month, because there are 59 days in a lunar month, and in 2 lunar months rather, so in half of that there's 29 and a half, and 29 and a half, although they haven't got numbers to represent 29 and a half, they know that 2 are a whole number of days fairly accurately. Now this principle of using longer counts, which is well known in areas of the New World, like the long counts of the Mayan cycle, which can last over thousands of years. This particular day count system can be extended to observe the moon and the sun, because the way in which the moon in its 12 monthly periods fits into the solar year effectively gives you a ratio from which you can predict and know a great deal about the relationship between the sun and the moon, the two most important luminaries that we experience. To extend to counting 12 lunar months relative to the year with its full seasons, one notices that there is about a third of a month left over, a little bit over. And this means that in 3 years there is an extra lunar month, so that in 3 solar years you get 37 months, and in 3 lunar years you get 36. And this can be shown using a form of differential display which will illustrate the intuitive powers of this form of mathematics as practiced by the Megalithic people. The natural evolution of stone counts is towards the equidistance, since this then represents not just a measurement, but also a measurement of time passing, so that on this device we've shown as the holes marks which are 1 inch apart, and therefore you are able to count. We're going to initially say that we're counting whole months along this line, and in a sense the entire month exists, whereas in the original Stone Age marks they were irregular and there was no thought about there being particular regularity apparently. In this case we can see the benefit of having a continuity of the inch counting, because you are starting to arrive at the portrayal of time itself and how number is superimposed by the events of the day, the month, and a lot further along the years. Now the motif used here is perhaps symbolic as well, because in the megalithic world you are seeing the sunrise during the year over different mountains or objects on the horizon, and set as well. And there is a wide tradition that's come to us of the sawtooth, in a way the jaws of the alligator that eats the sun when it goes to the west. And so it's appropriate to say that each of these inches, in this case we're calling them months, are being marked and counted out. And as we go to the number 36 that we just mentioned, this would be 12 plus 12 plus 12, 3 lunar years. But when we observe the time taken for 3 solar years, that's 3 entire rounds of the seasons, then we count about 37. And to compare these two is relatively simple through using the process of angling them from the start of the count, thus forming what we would call a triangle, but is in its essence a simple representation of a fundamental ratio between two numbers, But this is long before any concept of division as we would have it today, because we haven't even really got numbers, we've just got these lengths. So if I put a piece of wool in here and a weight on the end using gravity, then as I bring this up, there'll come a point where the weight begins to touch 36 down here from 37. So at that point we have what's called a right angle triangle, again in the way we conceive of these things. Here we have a right angle which gives very special properties to this ratio, and in our mathematics this would be called the cosine of this over this, from which we can calculate the angle here. But in primitive terms, but not necessarily inferior terms, you have here a slope angle. And a slope angle is something that one finds in pyramids, and it can also be found in any alignment on the ground where things are like this, only horizontal, or with mounds such as Silbury Hill at 30 degrees. And a whole range of all possible ratios between related time periods are exposed, and you can work with them by using this technology. So in this case we have coming down to 36, and it's been later on in our talk Robin will introduce what was a major discovery for him, which was that the form of a diagonal of 4 squares by 1 square high leads to this ratio which generates this relationship between the sun and the moon. And evidence of an actual one of this nature has not been found, although it's implied in various sites in Britain, megalithic Britain, that's Great Britain. But recently Robin has found one in the Carnac area of Brittany, and we can test this hypothesis by coming to 24 here, and what we find is between this row of dots and this row of dots we get 6, and there are 4 6s in 24, so that's in 2 lunar months relative to 2 solar years. And so the principles of geometry are starting to appear, and the other thing that we notice is that because this is 1 to 4, that we have a way of perhaps finding an exact geometrical construction from the process of making counts. So it's worth discussing the history of how Robin and I became involved with Howard Crowhurst and the work here on the Carnac complex megalithic site. In 2004, Tony Blake asked me to do a tour for a group of people who'd been to many places around the world, Egypt and Peru for instance, and asked me to help him put together an itinerary which we were going to include Carnac as an exploration of the megalithic culture. There were other reasons for it, to do with its longitude, and we arrived in 2004, and Howard, by some miracle we discovered of Howard's existence in Carnac, and immediately we found somebody who had been interpreting the monuments for over 20 years. 3 years later, 2007, my brother and I both were invited to come and give talks and generally enjoy the wide range of monuments in Carnac by Howard through the local tourism office, and we managed to see a more extensive picture than just my original overnight, although Robin had sort of slept around in a van in Carnac a number of years before, doing a bit of megalithic research. So we toured the sites and ended up at a site called Lamanio, which is famous for its quadrilateral and its imposing menhir called Giant or Giant. And the structure is geometrically very interesting and was surveyed by Tom in 1966 to 7 period, when he came armed with his British results, and he was challenged by academia, archaeological academia in Britain, to demonstrate his ideas about the megalithic yard and other principles of construction of megalithic monuments by going to a new region altogether. And so he did that with a lot of volunteer effort and came back with some very good site plans, one of which was Lamanio, which has been very helpful. Robin Heath came back in 2009 for another solstice event, and at that time ASEM, which Howard had helped to set up, an organisation for studying the monuments, had done a survey using theodolites, which they'd started to use on site at many places, and did a survey of Lamanio, which proved to be extremely interesting, because although in meters you get numbers, in megalithic yards for the area that Tom had discovered by analysing many of the monuments, he'd come to a kind of average. That in megalithic yards, perfect 3, 4, 5 triangles were marked out, and indeed at Carnac, uniquely at that latitude, the 3, 4, 5 triangle gives you the midsummer sunrise and sunset, and the midwinter sunrise and sunset to the north and south of an east-west line, and so they were evidently able to use, and possibly were drawn to working at Carnac, the original megalithic builders, by this property of having an easy geometrical, almost miraculous relationship of the simplest of the Pythagorean triangles 3, 4, 5. Whilst Robin came to Carnac, I'd been working on something I called the Itinerary for Megalithic Discovery. And this was a trial document which went through many revisions, in which eventually the hypothesis was became quite clear that there had to be some mechanism that wasn't using modern number or even Sumerian number in order to arrive at these structures and results, and that the subject of study had to be astronomical and not particularly commercial. And so by the time Robin came back, I had this concept of counting with the inch, which we've already been introduced with, this device in front of me. And we just need to say that whilst Robin was in Lamanio, he also made the observation that there was a 14-degree angle that was quite clear between the sun gate at Lamanio, which is two rather like teeth, give a southerly entrance to the quadrilateral, which is no, more like that, and it went at 14 degrees to the in the easterly direction and struck a stone which was dressed, which is being called in the surveys stone R. And furthermore, beyond that was found a grooved stone called G, and the grooved stone marks the midsummer sunrise. And so this lunation triangle, the bit of it that we can see here, in Robin's eyes, was pointing towards the midsummer sunrise, and also it had this property of being calibrated in inches when he did a proper survey of it, exactly in inches, as if it was for a single year, but there were 3 inches for every day. Well, when Robin came back, it became obvious that the 3 inches to a day could equally be 1 inch to a day, and the whole of the period measured along the line of the midsummer sunrise could well be the 3-year solar year period that formed a count. A count that was conducted prior to the building of the quadrilateral itself, and later monumentalized with a dress stone at the end of the count, and either the sun gate or a similar marker stone at the beginning of the count. And so an authentic actual inch count had been conducted, and was then monumentalized and built into a complex set of relationships that later elaborated the monument itself, the quadrilateral. Now the properties of this triangle are studyable, because you've done what is quite a complex investment of time over 3 years. Those 3 years will have run in inches up to this point, which is 37 lunar months, and then we've got 36 lunar months down here, and when we measure by arcing down to this point from the apex, we get the megalithic yard down here. But the megalithic yard is found to be 32.7 inches, whereas the month in the actual day count, we know, is 29.5 inches. And so something has happened. They appear to have adopted this unit in order to, as a building unit, and not used the 29.5 inch unit. So there must be some benefit that the 32.7 inch unit is giving us, giving them. So you can observe, and I think there was time for people to observe and to study every aspect of the geometry that they had created flat on the ground at Lemanio. And if you count back 9 lunar months and bring it round to here, you will find that there's the equivalent of 9 months vertically. And this is tremendously important, because 36 is 9 times 4. And so 9 months, 9 months, 9 months under 9 months is 4, and then 9 months gives you 4 squares. And 4 squares is the geometry that defines the lunation triangle which Robin Heath found as the perfect way of geometrically arriving at the relationship between the sun and the moon. So in this case, the accuracy when you start building 4x1 triangles is better than doing it through the observation itself of counting with the inches. And it is reproducible anywhere that you wish to do it. And so it's a bit like the discovery of an industrial process for making something. You can make this ratio without having to do the original work to find it in the first place. And the second step that appears to have occurred is this transfer to using the excess over 3 years as representing a month instead of the 29.5 inches that was manifest as the exact day count of a month. So it's worth reflecting on the implications of this procedure, because by using an inch and doing a count, one is able to achieve over a fortunate period of time concrete results that correspond with a unit that is found on the site as a unique signature of a unit of length, the megalithic yard. And this begins our entry into discovering actual measures that were used from the megalithic onwards through to the historical period in which there were many different measures of a certain interrelated character. And it's interesting to reflect that to achieve this in different areas required the transmission, say from Carnac to southern Britain, of a standardized inch, which is of course, as well-known fact, the dressed width of a push-down or dressed thumb. The thumb consumes an inch in width, but having achieved some kind of a standardized inch, the procedure of using a thumb would have been superseded, and a small and very portable unit, the inch, can conduct a new 3-year count in a new area and achieve a localized value to reproduce the megalithic yard if required. And Alexander Thom, in his studies of Great Britain and Brittany, did discover that different regions had slightly different megalithic yards, and it's conceivable that these did arise through the diffusion of this basic technology of using an inch to do the count, derive your megalithic yard. Once you've arrived, it takes you 3 years, but maybe it has a symbolic significance, and then you are moving into whatever experiments you are doing with similar triangles and other alignments in the landscape. You are moving on to a whole project of work. And it's worth reflecting also that as you start to measure things over even greater distances, because the 3-year count is going to be, say, 88 feet long, over even greater periods of time, the counts that you'll be looking at, or the measurements you'll be making to get high accuracies for alignments, will be large distances. And these are the large distances that require the large stones to be put in place to commemorate or even mark for the purposes of measurement. And so the megalithic culture, because measure is being used, the megalithic culture requires to build in large stone over large scale lengths. And because metrology is where you are storing your numbers, you cannot detach yourself from the numbers that are in the measurements, exactly because you haven't developed a numerical notation or an arithmetic to achieve those results in any comparable way, and Therefore, it's an independent culture of from the Fertile Crescent that's been produced there in the megalithic European phenomenon.